Now you have looked at cells, we can introduce skin. We will look at its structures, functions, and why it's important as a sports massage therapist to understand it. You will find further information in your manual under Unit 1, Section 2. The skin is the largest organ of the body and is referred to as the integumentary system. It is an incredibly complex and interesting system that has numerous functions including protection and production of chemicals. Everyone's skin is different and it makes up approximately 10% of the body's weight. It will vary in thickness from the soles of the feet being very thick to the eyelids being the thinnest, less than 1/500th of an inch. Understanding the skin will allow you to understand your client better, enabling you to feel a variety of inconsistencies. Looking at the skin will help you to evaluate your client's lifestyle, as it will show you stresses, hormone issues, hydration, and nutritional habits. Let's look at why understanding the skin is important. It is your first point of contact physically with your client, and everything you do is through the skin. You cannot directly see or touch the tissues you are treating, therefore understanding and working with it is key. If the skin is significantly warmer in an area, coupled with redness, swelling and tenderness, then this could be a site of injury or infection. If the skin is cold and has a vague blue tinge or mottled appearance, these tissues may be starved of oxygen, due to the circulation being compromised by the tissues in the structures below. The skin might not be very mobile or have a preferred direction of movement, potentially indicating that the fascia beneath the skin is bound or stuck. If there is drag or tension within the tissues, again there may be an area of dysfunction, such as an adhesion within the muscles below. You will be able to see and feel if someone's skin is dehydrated. It will be less elastic, so reluctant to return to its original position. It may also look and feel slightly powdery, and you may require more massage lotion. I just mentioned a term you may not be familiar with, fascia, and it is a fascinating topic in its own right. Although not heavily covered in this syllabus, we will include lots of additional resources for you on the topic. But put simply, if that's at all possible, it is found everywhere in the body and will wrap around everything. Seen under a microscope, it looks like a three-dimensional, slowly moving cobweb. It is a form of connective tissue. The statement "you are what you eat" is very true. The skin is very quick to give away poor nutrition, leaving the skin feeling and looking oily and sallow, or dry and flaky, or even spotty. This may also be the symptoms of a hormone imbalance, so with everything in the human body, don't jump to conclusions, ask questions. Although you shouldn't get involved in your client's eating habits, the information will help you in other ways. It will give you an indication on their commitment to themselves. Are they going to stick to a rehab plan? Are they going to work on their posture? If they're not going to look after themselves through diet, getting them to stick to a rehab plan may be very difficult. The skin will give away if your client is ill, coming down with something or had an extreme night on the beer. It will feel warm and clammy and almost sticky. You'll know exactly what we mean the first time you come across this. As well as receiving a large amount of information from the skin, you will also have a direct effect on it. As you mobilise the tissues, you will increase and improve the skin's elasticity. You will have an exfoliating effect on the skin, removing dead skin cells. This is one reason why it is so important to have good hygiene. You may cause the skin to redden. This is known as erythema. This indicates a greater blood supply to the area, bringing with it oxygen and nutrients. Finally, the stimulation of sebaceous glands will increase oil production, better lubricating the skin, which decreases the risk of drying or cracking, which in turn improves the skin's natural protection. So as you can see, there is a lot to be gained from understanding the skin, and the more people you work with, the more you will see the slight nuances the skin has to offer. Now you understand the importance of the skin, let's move on to the structure. The skin has three layers. These are the epidermis, dermis and hypodermis, commonly known as the subcutaneous. The epidermis and the dermis are considered the two main layers. The epidermis is the outermost surface, the bit you can see and touch, and can be further divided into 4 or 5 layers of cells depending where in the body it is. So for example, the soles of the feet will have 5 layers, but most of the body has 4. The dermis is situated below the epidermis, where such structures as blood vessels and nerves can be found. It also feeds the epidermis. Underneath the epidermis and the dermis you will find the subcutaneous layer. Looking at the epidermis first, it has no blood or lymph vessels and relies on the structures below to feed it. Oxygen and nutrients are passed to it via a process called diffusion. This will be discussed within the session on the respiratory system. There are hair follicles present in the epidermis which allow hairs and secretions through. The 5 layers of the epidermis, starting from the most internal level, are the basal or stratum basale. Stratum meaning layers. Think base. This is the deepest layer of cells and is sometimes known as the germinal layer. This layer constantly produces new cells to replace the dying skin cells on the surface. This is due to the epithelial cells continually dividing within the basal layer. The fully formed basal cells are pushed up to the next layer, which is the prickle cell layer or stratum spinosum. The name derives from the fact that these cells appear prickly. The prickle cells move onwards and upwards and lose their prickly appearance and start to flatten and become part of the granular or stratum granulosum layer. This layer gets its name from the granular appearance the cells take on from the keratophyllene. This is a chemical precursor to keratin, which we will look at shortly. The next layer is the additional layer. That is only found in the thicker areas of skin where a lot of friction occurs, such as the soles of the feet and palms of the hand. This is known as the clear layer or stratum lucidum, named due to its thinness, making it hard to see. The final very outer layer is the horny layer or stratum corneum. The cells are now dying and are becoming keratinized flat cells that create the waterproof barrier which protects the internal structures. There is around 20 layers of cells here that slowly die and slough off daily. Keratinized is when the cells become full of keratin, which is a protein found in skin, hair and nails. It creates a protective layer on the outside of the skin, making it more durable as well as helping to adhere the cells together. The cells take approximately 4 weeks to travel from the basal layer to dying and sloughing off. Other specialised cells can be found down in the basal layer. These are melanocytes and Merkel cells. We will touch on these shortly. Below the epidermis you will find the dermis. This is much thicker and has 3 divisions. It is mainly formed from connective tissue, a mix of collagen and elastin fibres, creating a tough, supportive structure. Within the dermis there are numerous other structures such as nerves, lymph and blood vessels, sweat and sebaceous glands, hair follicles and even fat cells. Looking at these structures in slightly more detail will help you to understand the functions of the skin. Attached to each follicle you will find a small muscle. This is the erector pili muscle. This is a smooth involuntary muscle, so you have no control over it, and its role is to make your hair stand on end, causing goosebumps. Next you have sweat glands, and there are 2 types of these, the eccrine and the apocrine. Eccrine glands are responsible for excreting sweat onto the surface of the skin, whereas the apocrine work slightly differently and are found in specific areas of the body such as the armpits, ears and eyelids. Rather than directly excreting sweat, they excrete it through the hair follicles, and their secretions are thicker and stickier, starting initially as odourless but smell as bacteria breakdown occurs. Sebaceous glands produce sebum, which is an oily substance that helps to protect the skin by maintaining its suppleness. Sebaceous glands secretions travel via the hair follicle. The sebum is made of cholesterol and fats released as the cells of the gland break down. This type of gland is known as a holocrine gland, meaning its secretions contain its own disintegrated secretory cells. Sensory nerve endings will be looked at in far more detail in a further section, but simply they detect pain, pressure, hot, cold and touch from the surface of the skin and relay that information back to the brain. There are a large number of sensory nerve endings running through the dermis. Blood vessels are covered in the circulatory system in more detail, but for the purposes of the skin, capillaries supply oxygen and nutrients to the tissues and structures of the dermis. Last up are lymph vessels. This is another important structure and will be covered in more detail in a later section. In this capacity, their role is to collect interstitial fluid. This is the term used to describe fluid found within the tissues. This is returned to the blood supply. The subcutaneous layer, also known as the hypodermis, giving rise to the name hypodermic needle, is the deepest layer of the skin. It comprises of adipose tissue, fat, and connective tissue. It houses larger blood vessels and nerve endings than the dermis and aids in insulating the body. The fat can be broken down as fuel for the body when needed, and the subcutaneous layer connects the underlying structures to the dermis. Last but not least are the functions of the skin. From the information we have already covered, you can probably work out some of the main functions. Put simply, they are protection, regulation of temperature, excretion, sensation, secretion, and formation of chemicals. So what does what? The skin protects in a variety of ways, firstly from infection. The horny layer of the epidermis creates a solid, interlocking keratin-filled layer which helps to prevent infection and unwanted substances gaining entrance to the body, coupled with the skin's acidity being of a hostile environment for bacteria. Nerve endings will prevent injury occurring by sensing heat or pain and passing the information on. Melanocytes control the level of pigment in the skin by producing melanin. When the skin is exposed to UV rays, the melanocytes increase the level of pigment in the skin, creating your tan. This helps to protect the structures under the epidermis from the UV rays. The adult body likes to operate at around 36.5 to 37.5 Celsius, and it really is quite fussy about this. If the body temperature drops to 35 Celsius, you will go into hypothermia, and if it rises above 40 Celsius, you will be looking at heat stroke. The nerve endings are constantly sensing the environment inside and outside the body, and if there is a temperature change, the body will respond. If it is getting too warm, the capillaries in the skin will dilate. Dilation is when the blood vessels increase in size, allowing heat to leave the body by conduction. Also, sweating will start. As sweat is 99% water, it will cool the body as it evaporates. If, however, the body temperature needs to rise, the capillaries will vasoconstrict, get smaller, to hold heat in, and the body's hairs will stand on end to hold warm air against the skin. Excretion of sweat, also known as perspiration, is 99% water, with trace amounts of salts, fats and minerals making up the remaining 1%. An adult can lose as much as 2 to 4 litres of sweat an hour, so staying hydrated is important. Sweat smells once it reacts with bacteria, but everyone's sweat smells slightly different. It can be affected by food, alcohol, medication and drugs. Sweating for temperature control occurs all over the body, but when it is emotional, it is limited to the palms, soles of the feet, armpits and forehead. Sensation. This allows all the other functions of the skin to take place. The sensory nerve endings constantly monitor the internal and external environment of the body, detecting small changes and passing the information on, keeping the smooth running of the body and maintaining homeostasis. The specialized Merkel cell is responsible for sensing light touch. Secretion is the production of sebum, which helps to maintain skin health, lubricating the skin and protecting it by creating that slightly acidic environment when it mixes with sweat. The acid mantle of skin is around 4 to 5.5 pH. Finally, the formation of chemicals. So this is melanin to protect, as already discussed earlier, and also the formation of vitamin D. This is produced in the epidermis when the skin is exposed to the sun. You do not need to develop a tan to create vitamin D. Various factors will affect how much is produced, such as skin type and colour, time of year, amount of time in the sun, and how much skin is exposed. Vitamin D, among other things, aids the absorption of calcium. We have now covered everything you need to know about the skin. You will now be able to complete the skin tasks. Once completed, you will be able to move on to the next tutorial. You will find questions about the skin in your theory exam.